transform the circuit into the S domain. You need to know the initial values in order to do that. And then you're going to use KVL, KCL, node voltage, Ohm's law, any other of the techniques to be able to set up the set of equations and solve those for whatever variable you want in the circuit. And it now can be any variable in the circuit instead of just the voltage across the capacitor or the current through the inductor. So it can be a complicated location in the circuit. Then you're going to manipulate that solution to get it into a match with the Laplace transform tables. Unless you want to do the Laplace transform, then you can, but I suggest that you move it to the Laplace transform tables. So a lot of times you have to use partial fraction expansion to be able to do that. And then once you do that, you can then match it up and change it back into the time domain. All right, so we're going to go through an example. So the first one here is this circuit. All right, so what do we want to do first? Okay, so we need to find the initial conditions by looking at our input source. So before time 0, your source is going to be 0. So that's going to be where you're going to look at that initial time. So the circuit, I'm going to redraw that, and that's going to change your input to be 0. So V is going to equal 0. This is going to be a wire. We're going to look for IL, and then this is going to be an open, and then we're going to look for VC. So we have both initial conditions will be 0. Okay, so we need to convert all the elements to the S domain. The values of each of these components is going to change. So the 11 UT translates to the S domain as U of T is 1 over S. And then the value of 11. So R's all stay the same. So 2 for R1, 4 for R2, and 6 for R3. And then what does the inductor become? What about the capacitor? So this is LS. And C in this case is 0.5. So you can write that as 1 over 0.5S, or you can write it 1 over 0.5 is 2. So you can write it 2 over S, either way. So now we're going to solve this circuit. I'm going to label this V1 and this V2. So you guys know I kind of like node voltage. So I'm going to use node voltage here. So I'm going to describe these 3 currents. So I start, when I have the arrow, I start at the positive side and I subtract off anything on the negative side. So that's going to start with V1. So you would do 11 over S over 2. All right, the one going down through the S, it's going to be ground. So if you don't see it, make sure to put in ground. So that would be my V1 minus 0 over S. And then the one going through the capacitor, correct, 2 over S. And that's one of my equations. So I'm just combining all of those together. All right, my second equation is going to be this current, and this current. The one through the 6 ohms, the one through the capacitor, and the one through the 4 ohms. So I can solve this one for V1 and then plug in here. And now I have one equation with one unknown. I'm going to try to simplify this as one common denominator. So this becomes S plus 2 plus S squared all over 2S. And then I can invert that. So this becomes 2S. So add an S to get those. And then you can flip the other side. So this becomes 2S over S squared plus S plus 2. So these are going to cancel. All right, and then from here, we need to use partial fraction expansion. So we're going to get A over S plus B over S plus 0.77. And then it's going to be the AB and B prime. And this is going to be 4.4 for A, 7E to the minus 75.15 degrees. All right, how do we translate these back into time? V out is going to be this V2, so V out of T. Okay, so 4.47 for capital A, so 2 times 7. So it'd be 14. E, and then what is small a? Correct, so minus 0.77 T. Cosine, what's small b? 0.56 T. And then what's theta? It's going to be a negative 75. So you take the negative and negative, so that becomes a positive 75.15 degrees. And then U of T. So note here that this is a plus for when this is a plus. And in our case, when we have a plus, we have a negative. And so that theta will be a negative 75.15 degrees. So when you put it in there, the negative and the negative cancel to a positive. So you do have to look and see what matches up with the plus.